In this lesson, we are going to learn how to improve 3GS built-in materials. Because as you saw in one of the previous lessons, when you are using a shader material, you have to do almost everything from scratch. Like when we tried to animate the particles, we had to redo the size attenuation, about the pixel ratio, the colors and stuff like that. And we didn't do everything. So yeah, it's a lot of work. But what if we are happy with the result of, let's say, the mesh standard material, but still we want to improve it, like, I don't know, make like the waves we did for the raging sea or stuff like that. Well, maybe we have to redo everything. Just imagine redoing everything the mesh shader material is doing. That would take years. So no, we need another solution. And there are two ways of doing it. To improve the mesh standard material, we have two solutions. The first solution is to use 3GS hooks that let us play with the shader and inject our code, meaning that we will use those materials, but at a very, very specific moment, we will inject our code in the material. Another solution is by recreating the material, but following what is done in 3GS code, meaning that we are going to recreate it, but take like huge part of 3GS code in order to get the exact same result. So we create our own shader material, but inside that shader material, we put huge chunk of code from 3GS. And it's possible to do it. I mean, this option is acceptable, but the material can be really complex and we have to deal with a lot of uniforms, defines, extensions. We have to deal with the includes, merging, stuff like that. It's a lot of work, and it depends on each material you want to recreate. The mesh standard material, it's really long. It's a long process until you get it working with your own shader material. I did it many times, and I can tell you that every time it was a mess. And the problem is that you cannot see anything until everything is perfectly set the same way. So you have to spend a lot of time in the 3GS dependency in order to find out how it's supposed to be working. So instead, we are going to use the first technique, meaning that we are going to use the hooks to inject our code inside the material before it gets compiled. So for this exercise, we are going to start from this, and we are going to make the model twist, like do some kind of a strange animation, just to test if we can animate the vertices by using a vertex shader. And obviously, we will keep the default behavior, meaning that the lights, the shadow, the texture, the normal map, everything will still be working. As you can see, it's looking great. So yeah, as you can see, I started with the realistic lesson at the end of the realistic lesson, but I changed the model to use a Lee Perry Smith head. It's a very famous model. It just looks great. It's one object with a cool texture. No, it's not me. Please stop saying that. And yeah, it's a good start to test what we are going to see right now. So how do we hook materials? And as you can see, it's not that hard. Let's go. To hook a material, first you have to find the material. Where is my material? It's over there, right here. So find the material in the code. And to hook the material, what you have to do is material. Use the onBeforeCompile property. And this is, by default, I think it's null or something like that. Let me check. Yeah, it's an empty function, all right? It's an empty function, and we are going to replace that empty function by our own function. We can do function like that. Or we can obviously, oh, sorry, it's not function like that, it's like that. Or we can obviously use a fat arrow. And why not go for a fat arrow? I don't know why I put a default arrow here. Anyway, here, as you can see, this will be called, so log hello material, something like that, and we get hello. This function will be called automatically by the material before by 3GS before the material gets compiled. And we can get access to things inside of it by using shader, by using any parameter here. You put any parameter and you get something. And as you can see, you will kind of know what's inside that. We have alpha map, alpha test, AO map, something like clear codes, defined. And if you look closely, vertex shaders. And if you look again, what's the name of the other one? Fragment shaders. And if you look again, uniforms. This way we can access everything from here, and it's before the material gets compiled, meaning that we can change what's inside of that in order to achieve the animation we want to create, the vertex animation we want to create. It's as easy as that. But obviously we're going to do cool animation, so we're going to have quite a lot of work to do. So first we need to add content. We will use the includes. If you look at the code, let's say the vertex shader, because we want to do an animation on the vertex shader, you can see that it looks something like that. It's a huge code. And this code came from the Three.js dependency library. Let me check. Yeah. What we're going to do is simply replace parts of that code. And as you can see, there is a lot of include something over there. We're going to replace those. To inject our code, we're going to replace those. What we can do, it's what I recommend, is just to check the code inside the dependency, and we're going to do that. So you can go to Node Modules, Three.js. We already did that, but anyway, it's good to find it again. So Node Modules, just three, not Three.js, src, and the shaders are located in renderers shaders. And here you have all the shaders of Three.js with some in the shader lib and some in the shader chunk. Those are the vertex and fragment shader, but you don't have all the code inside. Let's say, well, let's get back to the point vertex shader like we did in the previous lesson, in one of the previous lessons. As you can see, this is the shader for the points material, and we don't have all the code. All we have the main, we have some code about GL point size, stuff like that, but mostly we have includes. And the includes will automatically include parts in the shader chunk. Like if you find log depth buff path vertex, I can search for log depth buff part vertex. Let me check. Log depth buff vertex, this one. All right. And you can find every includes here. This is the way of handling chunks of code by Three.js. This has nothing to do with WebGL. It's really Three.js looking at includes. Okay, there is a command here, and Three.js will include a command over, I don't know, where is the command? Yeah, this one. All right. So when you are trying to understand a code, well, you have to open each part too. Like you have to open the shader of the material, and then each chunk to understand what's happening here. And this is exactly what we are going to do. So we can analyze it, keep it open, and we're going to just search for what we want here, and keep the chunks open too. So it seems that in the main function, what we used to do, model position, view position, projection matrix, is not written here. So it's probably somewhere in those includes. All right. I'm not in the right one. Obviously, I have to open the mesh. So where is it? Mesh. Standard material, it's mesh physical material. Yeah, we can use the mesh physical material. Let me check if it's the one. No, I didn't write it. So it's going to be mesh physical material. It's the same. It's the same. So mesh physical vertex. This one, mesh physical vert. And as you can see, first, well, there is a lot of includes. And inside the main, we have some stuff about UV, UV2, color. All right. We have something about normals. Remember this one, morphing normal, skin, we don't care about those, skin, default normal maybe, all right, and then we have something about normal, tangent, all right, and then we have something about begin vertex, this is interesting, morph target vertex, no, skinning, no, displacement, yeah, we have displacement, but we don't care, project vertex, this one is interesting, the other one we don't really care, and then we have a V view position, it means that maybe we are sending it to the fragment. Yes, it is. So this varying is being sent to the fragment. All right, interesting. We don't really care about this one. World pose, probably world position. That might get useful. We're not going to use it, but still. Shadow map, fog vertex. All right. Always try to understand just by the names. The names are pretty cool, so we can understand. Obviously, do not change this material. We're going to use only the hooks to change the material we are using, not the material inside the dependency. And yeah, indeed, it's in the begin vertex, and we can check the begin vertex. So keep this one open, so the mesh physical vertex material, and search for the begin vertex in the shader chunks. And as you can see, that's all we have. Transform. Transform, which is based on the position. This is the attribute. I told you in previous lessons that you cannot just change an attribute, which is why 3GS here is just creating a new variable from that attribute in order to be able to change this variable. And this is exactly what we are going to do. We're going to change this variable. Well, because we can, because it's not an attribute, it's now a brand new variable, we will play with it. And 3GS, after the begin vertex material, so after that, uses this transform variable and do transformation, morphing, skinning, displacement, and stuff like that. And we're going to inject our code right here. So to inject our code, first, well, we can get back to our code. So it's this one. We are inside the on before compile. So to access the vertex shader, well, we can do vertex shader, as we saw inside this variable here. As you can see, we have access to this string, which is the vertex shader, which is exactly what we have here. And we want to change this. There is two ways of doing. What I've seen people do is to take this part of the code and to replace this by this and then change this, where there is a better solution. First, how do we inject code in a string? Well, we can use just a simple JavaScript by using the replace, and we are going to replace this. All right, we are going to use the includes in order to target a very specific position in the shader to replace it. So let's go. We are going to do, I can remove the console log and do vertex shader replace, and I'm going to replace this part. All right, so take the hash include begin vertex and replace it, and the second argument is replaced by what? For now we replace by nothing. If we save, we get not an error. Why? Well, I did a mistake. When you replace, it creates a new how do we say, a new string, so you have to put it back. So shader vertex shader equal this new string. I always do this mistake, my bad. Anyway, we get an error because right now we are removing this part because we put nothing instead of this part. Right here, we just kind of remove this part. So we don't have the transform variable anymore, and 3GS needs this transform variable after. What we can do here is just put it back right here. And because we are starting to have a long line of code and we are going to write a lot of things, we can do that, we can do that, and we can do that. All right, it's up to you, but we are going to write a lot of code, so let's do that. And as you can see now, it's working because I put it back, but right now I can inject my own code right here. And you can guess that we are going to have quite a few lines of code, maybe, I don't know, 10 lines of code to do the animation. So we need a way to write it more clearly. We are not going to put the shader in another file. We are just going to write it in multiple lines, and to write multiple lines in JavaScript, you can use back quotes or backtick, which name is template literal, and then do something like that. All right, we are just doing the same thing. It's just that now we can add our own code to change the transformed variable right here. So what can we do? Well, first, let's test that the theory is working. Because the name of the variable is transformed, what you can do is transform. It's a vector 3. It's just the position of the vertex, of each vertex at the end, is transform y plus equal, I don't know, anything, 1.0, why not? Don't forget that we are in GLSL, so use the 0.0 and don't forget the semicolon, and we get that. It seems to be working. I know there is a problem with the here, we're going to explain that. If I put more like, I don't know, 3, well, it's even higher. So we have control over the vertices with that. I know the shadows are broke, we are going to fix that. So it's working, let's remove our test and move forward. And we can do the twist. No joke here. So yeah, to twist the model, we need to do a rotation that vary depending on the elevation. What I mean by that, I'm going to use that beautiful drawing I did. So to do the twist animation, we don't need just to rotate all the vertices at the same speed. The idea is that those vertices will rotate, I don't know, like just a little. And those one will rotate, I'm going to use green. This one will rotate a little. This one will rotate a bit more. This one will rotate more. This one will rotate more. And this one up will rotate way more. And all around the center axis, right? That one. And that's all. We do a rotation around the center, and the higher, the more rotation. Or it can be the opposite, or maybe we can tweak this. Anyway, it's just rotate at different amplitude, I'm gonna say amplitude, depending on the elevation of the vertex. And that's all. That's all. I know it's not that easy. It's mathematics stuff. But anyway, it's the kind of thing you can just test. Oh yeah, it's working. Great. So let's move forward. And it's the way I do it. So we are going to start by rotating the whole model. All right, we just want to make sure that we are able to rotate the vertices, and then we are going to make the rotation change depending on the elevation. So first we are going to create a variable angle variable. So we can do float angle, and we are going to put anything in it like 0.3. Yeah, let's go for the 0.3. This is our angle. If it's more where the whole head is supposed to turn more. If it's less, where the head will turn less. We can save. Right now we are not using this variable. We just created a variable, so nothing changed. Because we put 0.3, maybe the head should be something like that, or maybe like that. And we are going to do things differently. I know we already did a rotation. I think it was in the shader patterns lesson. We did it also for the galaxy animation. We are going to use a matrix. Why? Well, just to learn how to use those matrices. It will be kind of useful. Indeed, you will see why later. But right now it's kind of far-fetched to use a matrix for that. But still, I want to show you how to use matrices. So matrices, maybe you remember we did use matrices to transform the position, to the model position, and then to the view position, and then to the projected position by using the model matrix, view matrix, and projection matrix. All right. Maybe you remember, maybe not, it's okay. The idea is that you have a value. This value can be a float, can be a vec2, can be a vec3, can be a vec4, and you apply a matrix on it by creating a matrix and then just multiplying it. And you will get this variable will be changed by what this matrix is supposed to do. Creating matrix can be really hard. I usually never create my own matrix by putting my own values inside. What I used to do is just like I take a function, this function provides me a matrix, great, I use that matrix. Or like I use the view matrix, I don't know what's inside the view matrix, I know what the matrix is doing, but I don't know what's inside the view matrix, I just use it. So right now what we are going to do is use a matrix that will do a 2D rotation. And you might ask, why a 2D rotation? Our model is in 3D. Well, because as you can see here, the rotation are only on the, let me draw them as usually, only on the Z, so it's more like that, the Z, and the, I'm going to use, this one, and the X, like that, because it's rotating like on the plane, like that. It's always rotating like that. It's not doing stuff like that. It's just doing rotation like that. It's hard to draw it because it's a 2D drawing, but anyway, we just rotate like if my head do that, it's just on these vertices will move just on this. So it's just a plane like this. So it's X and Z. I'm not going up or down. Anyway, we can just use a 2D matrix, and we are going to create a 2D rotation matrix. And I provide you the code, but I will also provide you an article from the book of shader on how I got this code. So it's just it's going to explain to you how to use it. So it's this part. It's not the translate. Yeah, it's the rotation. You can read it. It's as always articles from the book of shader are just great, and you can just use it. All right. It will explain how to do a rotation. I don't think it's the matrix. No, it's not the matrix. It's just how to do a rotation, but it's what the matrix is doing anyway. All right, cool. So you can get it from the code below. As always, just scroll below and you will get it. It will look like this. If you want to copy it, well, pause the video and copy it. But the question is, look at the function. This function will you provide an angle. So we are going to use this angle, and it will give you a matrix. It doesn't do the rotation. It provides you a matrix, and then you can use that matrix on values, on vector 2, because it's a math 2, matrix 2, 2D matrix, we can only apply it on vector 2 variables, which is perfect because for us it's x and z. So it will give us a matrix, and then we have to use it. So where should we put that function? Can we just put it there? No, we are supposed to put the function outside of the main function. See, it's like we are supposed to put it, I don't know, somewhere over there. So I'm going to remove it there. Don't put it there. So if we wanted to put it, I think it could be like something like that. This would be perfect. Yet again, we're going to take an include and replace it. And what can we replace? So this might change. No, this is a bad idea. This is a bad idea. I don't know about those. I don't know what is clipping, plain path, stuff like that. But I like this one. Common. We can have a look to common. See? It's, oh, see that? We have pi. Pi 2, great. We can use those. Pi half, why not? Reciprocal, epsilon. So we have like access to defined variables, to constant variable. And we have a lot of things, and actually all those things will be on every materials. I think every materials, anyway, it's you will probably have include common on every materials. So we can use that. We can capitalize on this because we are quite sure that we will have it on any material. So we are going to do exactly what we did with the begin vertex, but this time on the common part. We are going to duplicate this part. I will put it before so that we kind of follow the order. I will replace the common, so with 2m, I replace by the same thing, common. So I can just test by doing that, all right? Just to make sure that I'm not breaking anything. My code is still working. So the vertex shader will replace by the vertex shader where we added the same thing. And then we can add a function like that. Just like that. Still no error. If I do a mistake, like I don't know, I do something like that, it's not working because the code not working. So it means that we are indeed changing the vertex shader, but we are adding a function, but not using it yet. So that's cool. We now added a function right here. So it's after. I know it's kind of ugly to put things like that, but anyway, we don't see this shader at the end. We just inject our code inside. Even worse, we did like a indentation like that. So it will look something like a, let me check, please let me click, something like that. So it's even worse, but we don't care. It's okay. Indent doesn't change anything. So we did it, great. What we can do now is use that function inside our begin vertex to create a rotation matrix. So let's go. mat2, because it's the type. Remember that this is returning a mat2 variable. Rotate matrix, could have say rotation matrix anyway. Get, we just call this, so it's get 2D rotate matrix. So get 2D rotate matrix, and we provide an angle. We have to provide an angle. Don't forget the semicolon. Just save, and it seems to be working. We created that matrix, which will transform any, if you multiply it by any vec2, it will do a rotation on that vec2, which is great. It's like a machine, like we created a machine, we can put any vec2 variable in it, and those vec2 will be transformed to do a rotation. And this is like the most basic matrix possible. We can do like 4D matrices, 4-dimension matrices. So let's do the rotation. I will do transformed x, z, because we just rotate on the x and the z, equal, and we use the rotate matrix, or I did the opposite, but it's the same. We just need to multiply them. Transform x, z, like that. Finger crossed. Yeah, it did work, see? Perry's head just looked at us, which is kind of creepy. So we can change the angle. Let's put more, 9, and as you can see, it's rotating. So yeah, it's working. But still, we have a problem with the shadows. We are going to fix that anyway. But we have control. We can just rotate every matrices. We are using the rotate matrix, so maybe just invert them. My fault, sorry. It's more logical to have matrix and then the vector. And we rotate every vertices on x and z axis by using this rotate matrix. All right, great. So it's working. This is a way of using matrices. What we are going to do now is change the angle depending on the elevation. And you're going to see that it's very simple because we have the position. I use the position Y, but I can use the transform position. Anyway, it's the same. We will do position Y. Well, we can just use the position Y. So the angle depends on the position Y, and we can just save. And as you can see, it's working. It's working great. It's really creepy. There is still a problem with the shadow, but it's really working. I'm going to multiply it by 0.9. I don't know why exactly, but let's do exactly what I have in the examples. So as you can see, it's working. We have some things to fix, but the rotation indeed is working. It's not animated. We are going to fix that too. So see, with 0.2, like a bad morning, kind of sleepy. All right, let's move forward and let's animate it. So in the on before compile, we also have access to uniforms, and we can just log them to see what's inside. So log shaders uniforms. I will put the uniforms before the shaders, but you can put it after. It's the same result. And as you can see, there is a lot of uniforms. Those are mesh standard materials uniform, which is why we have a lot of them. And we have nothing about the time. So we're going to add our own uniform. So let's go, and we're going to do it just like we used to do it. So shader uniforms u time equal, and it's an object. Remember that we have to provide an object with a value like that. So we just do that. No error. Great. And then we can retrieve it inside the shader. So it's inside that. It's bad to have, I know, the no syntax coloration, but the code won't be that huge. But if you want to switch it to different files, you can. All right, maybe pause the video and do it. So retrieve in the command chunks. Yeah, so because we want to retrieve the uniforms like here as soon as possible, not inside the main function, well, we can still use the include command and retrieve it. And we're going to do that, let's say here, uniform, it's a float, and we named it uTime. Make sure you're not making any mistake. You can save. If you did a mistake like forget a semicolon, well, you will get an error. But if you wrote uTime wrong, you won't get an error because you're not using it, and it's okay, strangely. Next part, we can use it on the angle, so that the angle here will change depending on the uTime. So what we can do here, I'm going to add it to the y. Yes, why not? So I do plus y, but the multiply, I want to multiply the result of position y plus uTime. Let's see what we get. Okay, I think it's working, but the problem is that there is no animation. You can guess why, because we are not changing the uTime. So let's go. How do we change the uTime? Well, we go to the tick, and there is a problem here. How do we access the material uniform? If it were a shader material, where we could do something like material uniforms uTime value equals something. Yes, but it's not a shader material, and we cannot access those easily. I can show it to you here. Material uniforms, what do we get here? Well, nothing. We cannot access the uniforms like that. I don't know why exactly it's that hard. I hope maybe this will change, but still we cannot do that. Don't worry, we're going to fix that. So it's kind of a scope problem because we cannot access a variable. We did created a uTime, so it's over there. We did created a uTime here, but it was inside the function. We cannot access it from outside. There is multiple way of fixing that. It's just kind of a JavaScript hacks. All right, it's just that we need to access a variable inside a function outside of a function. I'm going to show you how I like to do it. We are going to create uniforms outside, just the uniforms. You could have like saved the shaders outside and then update it here. It's another way of doing it, but I like just to keep the uniforms outside. I will do custom uniforms equal, and I will put my own custom uniforms in it. All I have is the uTime that you will be able to add more later if you need. So value equal 0. So right now I created the uniform outside. I can change it outside, but right now it's just a variable with some properties in it. Doesn't mean anything. I'm not using it. What I will do now, instead of putting this here, I will use the custom uniforms uTime. And because it's an object, I'm not duplicating it. I'm not putting the value in here. It's the same object. That object here is the same than that object here. So if I change this one, it will change for this one too, which is great. It's the way of JavaScript handle the objects. If I change this one, it will change here. Even if I do it like in 10 minutes, I can change this one. It will change it for the shader uniforms uTime. It's a reference. All right, cool. So let's save just to make sure I didn't broke anything. And right now what we can do, because this has been declared outside of any function, I can just change it inside the tick function. So let me check. Yes. Yes, we can update the material. Let's do it. Update material. Now we do the same thing I did in a previous lesson. Custom uniforms uTime value equal, and I will use the elapsed time, so how many seconds since we refreshed. We reloaded the page and we get something like this. All right, it's looking really creepy, and it's even worse because of the shadows. We need to fix those shadows, but still we did it. We injected also uniforms, and you can add any uniforms you want, but also like tweaking uniforms to get to be able to tweak the twist or stuff like that. So it's time to fix the shadow, and we have a lot to discover here. It's not going to be that easy. Hang on. Remember that to handle shadows, Three.js do renders from the light's point of view. They are called shadow maps. Remember that when we have, let's say, a directional light, I think that's what we have here. Before each render, Three.js will put a camera at the place of the directional light and do a render of our scene in order to know what the lights can see, and it will create a render called shadow map, and this shadow map will be used to put shadows or not on the materials. And this is where the problem happened, because when Three.js is doing those renders, Three.js replaces all the materials of the scene, so our head, stuff like that, by a very specific material called a depth material. It's just that to create this shadow map, Three.js needs the distance, the depth of the things, and it will replace every material by this shadow material. And the problem is that this shadow material, so the depth material, doesn't twist. So we have the one visible that is twisting, it's our mesh standard material, but the one we cannot see, the one for the shadow maps, is not twisting. And we can do a test to confirm that. We're going to put our code, I don't know, maybe right after the model. Yeah, right here. We're going to create a plane. So it's been a long time since we did a simple code. So const plane, we're going to create a plane on the opposite of the head. So the light, the head, a plane, to see the shadow, and you will see something kind of creepy. So to create a plane, we create a new 3 mesh. We're going to provide a 3 plane buffer geometry. Remember those? It's important to remember basics. We're going to put a mesh standard material because we need the support of shadows, light, stuff like that. So mesh standard material. No parameters, is going to be white by default. Plane rotation y equal, plane rotation y, we're going to rotate it a little, math pi. Position, yeah, let's put it at the right position. And the z, so it's not at the exact position of the head, obviously. And we can add it to the scene add, like that. All right, let's test. All right, it's working. And as you can see, yeah, that's what I was talking about, kind of creepy. We have the head, imagine having your shadow, and you turn your head and the shadow doesn't turn. Damn, and even worse if your head is turning like that. So anyway, as you can see, the shadow is not turning. Remember that there is two types of shadow. There is the core shadow, it's the one on the model, and there is the drop shadow. We are going to focus on the drop shadow first. So yeah, let's go, let's fix that. We need to twist that material too. The depth material, we need to twist it too. Don't worry, we can do that. The problem is that we cannot access it just by doing something like my mesh, my depth material, and do some stuff on it. but we have a way of providing our own depth material, and we are going to create our own mesh depth material. So it is this one. I can show it to you what it looks. So it looks like that. And we're going to create our own depth material and provide it to the mesh and say, all right, from now, you're going to use that one instead of your depth material. And that's all. So let's go. And we're going to twist it, obviously. So it's with the custom depth material, and it will look something like that. So let me check where to put the code exactly. No, I'm going to create it right after creating the material, so the mesh standard material. We call it, because we only have one material in our scene, we can just call them material, depth material, stuff like that. But obviously, if you have multiple objects, we'll have to name them correctly. So depth material, you could have called it like maybe shadow depth material, something like that. It's going to be a 3 mesh depth material. So it's the one I just shown you before. So it's this one. But we also have to provide a parameter, which is the depth packing 3 RGBA depth packing. This parameter will change the way it looks. Right now, by default, a depth material looks like this. If it's close, it's white. If it's in the far, it's dark, so it's black. And by doing that, it will encode the depth in different channels like R, G, B, and A in order to have more precision. It's just a tip, like a hack to save more data by using different channels. We don't need to understand that. I just know that Three.js is doing this, and we are going to do the same or it will break. So we put the depth packing RGBA like that. Actually, maybe I can show you. I want to show you. Or as I say, I just want to show you stuff. Yeah, it looks like this. See? And it looks really strange because we are encoding in a multiple RGBA and we get a much better precision. And then Three.js will decode this data and get a better result. Anyway, let's get back to the result. Don't change it. I just wanted to show you. And by the way, the depth material, as you can see, it's not doing any stuff like that. This is the problem. So let's get back to the material. Okay, cool. That was a great example, actually. Be careful, I did a small mistake here. It's not depth material, it's depth material. So now that we have our depth material and we've seen what it will kind of look like, what we can do is tell our mesh to use that depth material. So let's go. We can just scroll to where we loaded the material and where we replace the material of the model we loaded. And we can do mesh, and it's going to be custom depth material equal our depth material, like that. All right, and it seems to be working just the same. If we did a mistake here, well, we probably get an error or no shadow or something like that. So anyway, let's move forward. What we are going to do now is exactly what we did here with the material. We are going to hook the material, so the on before compile hook, and put our own code in here. So let's go. I'm going to do it after. It's the part where you might get lost. Be careful. This is our on before compile for the material, and we are doing the same thing here. So depth material, we want to hook it the same way. So on before compile equal, we use a fat arrow, shader. Let's log it and we can do some tests. All right, so we get exactly the same kind of thing. So we get the uniform, the vertex shader and stuff like that. If you want, you can just do a test. I'm going to replace, so it's this part. Remember, I'm going to do to move it up a little. You can test with me. Shader vertex shader equal shader vertex shader, but we replace a part of it. We're going to replace the same thing. So include begin underscore vertex. I'm not going to check the material in the Three.js library because I know it's the same thing. We have the begin vertex and the command, but you may have a look to the depth material, to the depth shader material. So I replace this by the same thing just to check that I don't break anything. All right. Then I can inject my own code. So I'm going to use back quotes in order to put line breaks like that. And I will do transformed y plus equal 1.0. I just move the shadow up. and it's not working. Let me check why. Transform Y, maybe more. So it is working, it's just not enough. As you can see, it's working. The shadow went up. We had a kind of strange shape, but anyway, it's working, which is what we wanted. So if I put 3, I think it's because it's the limit of the shadow map amplitude. So anyway, it's working. I can move the shadow by changing the depth material. Really strange, but it's working like that. So we can do the same thing. We're going to, let me check, we're going to do the exact same thing. So we can actually just take the code, like take this part. So we are creating the U time, get rotation. I'm on the material on before compile. Follow me on this. I will take everything. I can just take everything. No, we cannot use the same function, but because you will see that we are going to do more changing after, but only on one of them. So take the whole code here of the material on before compile and put it in the depth material on before compile. Like that. Did I do something wrong? I don't know. No, it's fine. See how my head is turning? Not my head. Liz Perry's head is turning. Yeah, now it's working great. So we fixed it. Did we? No, we still have a problem on the model. See? We did fix what we call the drop shadow, but we didn't fix the core shadow. Drop shadow is the shadow on the other objects, and core shadow is the shadow on the object itself. So the back of the object in the darkness, the dark. So we need to fix that, but we are almost there. It's a normals problem. The normals, remember, are data associated with the vertices that tell in which direction is the outside, and it's to be used for lights, shadows, reflection, refraction, and stuff like that. I can, as always, do a small drawing. If we had, I don't know, this vertex is normal, it would look something like that. The vertex is here, will be over there. The one here will be over there. There, one on my here, something like that, all right? It kind of gives you the direction of the outside, so that we can do formulas to see if the light bounce, the shadow should be here, or something like that. When we did a rotation, like let's say a rotation of this part, so the normal was going this way, all right? This one here was going this way. We did a rotation, so now the vertex went from here to here. You agree with that? It's the twist animation, but the normal direction didn't change, meaning that this is going there, which is wrong. This one is supposed to go there because we rotated the vertex. Now it's supposed to look somewhere else. If we did, I don't know, this one, and now we did the twist and my here is at the opposite, well, let's imagine you have a here over there. So it's going to be something like that on the opposite. The normal, we still say that it's going this way, which is wrong. What we need to do is rotate the normals too. Should be easy. We know how to do rotation. The shadow, by the way, the shadow is only applied on the default material and not the depth material, which is why we did duplicate everything here. I know it's currently the same code, the on before compile of the material and the on before compile of the depth material are exactly the same, but we are going to change only this one to fix the core shadow because there is no core shadow on the depth material. All right, so let's go. What do we want to do? Because it's about normals, do we have something about normals in here? Normal, yeah, we have a lot of things about normal. We have begin normal, morph normal, we don't care about morphing, skin normal, we don't care about skin, default, this one can be interesting, normal vertex. Then we have something about flat shading, you know, when you can see it's not like smooth, it's not brown, it's flat. In our case, we don't care. And then that's all. So it has something to do with begin and default normal. And this is the moment where you just try to explore the dependencies to understand which one you need to rotate. I will tell you that it's in the begin normal vertex, and you can have a look at it. So begin normal vertex, it's this one. And as you can see, so we don't care about tangent, all right? You usually don't need tangent. Very specific situation, maybe you will need a tangent, but let's not talk about tangent. And we have the object normal, which is using this normal. This is the attribute. This is just a variable in order to be able to change it. Just like we had the transformed, we have now the object normal, and we can do animation on the object normal. And this is exactly what we are going to do. So let's go. Can we do the same thing? Well, let's try. I'm going to change the begin normal vertex. So first, what I always start to do is just try to change it. And I will just keep the order. I like to keep the things in the same order. It's not that important, but still, it's a good thing to keep things in order. We have the common and then the begin vertex. Is my begin normal vertex after, before, in the middle? Well, you can just check there. I have the common at the beginning, and the begin vertex after. So it's right between those. So I will put some code right between those. So let's go. I will do this, replace. And I will replace what I said. I'm going to replace the begin normal vertex, so this line, by the same line to start with. So I replace this. So I duplicate it. So it's shader, vertex, shader, equal, shader, vertex, shader, replace. And I replace this by something else. And I just put back the same include because Three.js needs that include. I just save. I make sure I didn't break anything. And it seems fine. All right. If I do a mistake here, I get an error, meaning that I do changes. I did some changes, but I put back the same thing. And right now I want to do rotation. What could I do? Well, maybe I can do the exact same thing. So I have access to the get to the rotate matrix. Remember that it's at the end, it will be in the same code. Maybe I can do this same thing. So this is my begin vertex. This is my begin normal. Maybe I can just take this part, put it there, but I'm not going to change the position. Well, I'm going to use the position as the reference, but I'm not going to change the position, the transform. I'm going to change, remember, it's object normal. All right, I want to rotate the normal. The name is object normal. I know that's a lot to remember, but maybe do the lesson again at the end. So I'm going to try to rotate this object normal. I save and I get an error. Did I do a mistake? No, I don't think so. I have my float angle. I have my rotate matrix, and then I try to use my rotate matrix on my object normal, which is a vector 3, but I just do it on the XZ. I didn't forget any semicolon because I just copy and paste. If you look at the errors, because it's always good to look at the errors, you can see that angle redefinition and rotate matrix redefinition. Remember that those are just chunks of code that will be put in here. So it's like having the code without the include. So you get the begin normal vertex and you put it there. You get the morph normal vertex and you put it there. You get the begin vertex code and you put it there. And this is the problem because we are having the same variables on the same function, on the main function. We have float angle something, mat to rotate matrix something, and we have it twice inside the same function. It's just a syntax error. We just declared the same variables twice. So we can just use the same variable because it will be at the end the same code. We can maybe just remove one, and this is exactly what we are going to do. But which one? Well, because I told you to put them in the right order, you can just read the code and say, all right, this one has nothing to do. Then I create the angle. Then I create the rotate matrix. Then I use it. And then here, this code happened. And we don't need to redeclare the angle and the rotate matrix because it's the same matrix, because it's the same angle. And you can just get rid of this part because we already created the angle and the rotate matrix. So the angle is just for the rotate matrix. And then we create the rotate matrix. We use it on the normal. And then we use it on the transform. It's even better, but because our code is optimized, we just do one rotation matrix, and we use it for the normal and for the vertex position, which is great, which is why it's even better to use the matrix for that. And that's it. Look how creepy it's that. Yeah. Anyway. It's working. Great job. I know that was hard. That was a lot of things, variable stuff like that. But still it's working. All right. We will stop there. But what I recommend you to do is just to have fun with this formula right here. All right. Actually, there might be multiple things. First, yeah, you should add some tweaks. We didn't do that because I think the lesson were not that long, but really complicated with a lot of includes, replays, stuff like that, and many files to check in. So I didn't put the tweaks inside that GUI, but I recommend you to add them. Maybe you can just do, I don't know, 4. It's hard to find the right value. Well, maybe you can just, I did a mistake here. Ah, yeah, be careful. If you are changing one, you have to change it in the depth and in the other one. All right. So in the default material and in the depth one. So be careful with that. If you send a uniform, use that uniform in the depth material and in the material too. So if I put 5, yeah, it's looking a little better. Not too stretched. The second thing would be to move the shaders to different files. All right, we didn't do it because I wanted to be able to see all the shaders in one file, so that when I scroll, you understand that, all right, there is maybe multiple parts at the same time, but not having the color, the syntax color is bad. So maybe put them in files. And finally, yeah, you can test other animations. So what I will do is just provide you the one I really like, really strange. So what I do is that I change both at the same time, all right? I have my cursor on this one, it's the default material, and this one, it's the depth material. And one I like to do is to use the scene, and it will look something like, let me check. I put a scene here, and I multiply it by something a little less. Look at this. Oh yeah, that's it. I won't explain to you this part. Yeah, I could. It would take like 5 minutes, and I'm bad at explaining mathematics, so I won't do it. But just try things, have fun. Maybe mix this one with the previous one, and you will see that it can look like really creepy and strange. And as always, send me what you did. I can't wait to see your results. See you in the next lesson.